The next few minutes could save you thousands of dollars in repairs. And if you own a Volkswagen or are thinking about keeping one long-term, you're about to discover settings hiding inside your car that could quietly shorten your engine's life every single day you drive. Most drivers assume modern vehicles are perfectly optimized straight from the factory, but the reality is far more complicated. Deep inside your Volkswagen's digital systems are convenience and efficiency features that seem helpful on the surface, yet can gradually wear down critical components without you ever realizing it. These settings are rarely explained when you buy the vehicle, and many owners spend years unknowingly allowing them to chip away at reliability. The surprising part is these features weren't created to damage anything. Engineers designed them to satisfy strict emissions requirements, improve fuel economy ratings, and enhance comfort. Unfortunately, real-world driving doesn't always match the laboratory testing conditions these systems were built around. If your goal is to keep your Volkswagen running smoothly for years instead of trading it in before major problems appear, understanding these settings could make all the difference. One of the most widely debated systems is the automatic start-stop feature. It seems harmless and even clever. Each time you stop at a traffic signal or get caught in slow-moving congestion, the engine shuts off automatically. The moment you lift your foot off the brake pedal, the engine restarts instantly so you can continue driving. The system is marketed as a fuel-saving and emission-reducing innovation, but its long-term mechanical consequences often go overlooked. Starter motors in traditional vehicles are built with a limited number of ignition cycles in mind. Under normal circumstances, they might endure tens of thousands of starts across many years of driving. However, in city environments where traffic lights and stop-and-go traffic dominate, the start-stop system can cause the engine to restart dozens of times during a single trip. Over the course of a year, that can add thousands of additional starts, dramatically shortening the life expectancy of the starter motor. Batteries are also pushed harder than they were originally intended to handle. Each restart demands high electrical output, which leads to faster battery degradation, even in vehicles equipped with enhanced battery technology. There's also an internal engine effect that many drivers never consider. When the engine shuts down repeatedly, oil drains away from upper engine components. When it restarts, it takes a moment for full lubrication pressure to return, creating repeated micro moments of increased friction and wear. Disabling this feature manually each time you start your vehicle may feel repetitive, but it can significantly reduce long-term mechanical strain. Another technology designed to improve fuel efficiency is cylinder deactivation, often referred to as active cylinder management. Under light cruising conditions, the engine temporarily shuts down selected cylinders to reduce fuel consumption. On paper, it looks impressive, offering measurable fuel savings during steady-speed highway travel. The complication arises from what happens inside those inactive cylinders. While combustion stops, oil vapor from the crankcase ventilation system continues to circulate. Without combustion to burn off these vapors, they settle on intake components and gradually form carbon deposits. Over time, these deposits can restrict airflow, leading to rough idling, reduced performance, and misfires. Removing carbon buildup typically requires specialized cleaning procedures that can be expensive. There is also an uneven wear factor. Cylinders that remain active handle more workload, while deactivated ones experience less mechanical stress. This imbalance can create variations in compression levels between cylinders as the engine ages, which may eventually lead to vibration or performance issues. Many vehicles allow this system to be turned off through driving mode or efficiency settings, while others require diagnostic coding adjustments. Transmission adaptation learning is another hidden behavior quietly influencing long-term durability. Modern Volkswagen transmissions monitor driving habits and adjust shift timing and gear selection accordingly. The goal is to maximize fuel economy by encouraging early upshifts and maintaining higher gears whenever possible. While efficient, this strategy can cause the engine to operate under low RPM load conditions known as lugging. Lugging places extra stress on internal engine components like bearings and connecting rods. Dual clutch transmissions, which are common in many Volkswagen models, can also experience increased clutch wear if the system constantly prioritizes smooth, fuel-efficient engagement instead of mechanical preservation. Over time, learned driving patterns may push the transmission further toward efficiency rather than longevity. Resetting transmission adaptations occasionally or using sport or manual driving modes periodically can help prevent extreme fuel-saving behavior from dominating shift logic. Slightly higher fuel consumption may result, but it can help extend transmission lifespan significantly. Oil change intervals are another area where computer-controlled recommendations may not align with real-world driving conditions. Volkswagen's flexible maintenance schedules can sometimes stretch oil change intervals to 10,000 or even 15,000 miles. These intervals are calculated assuming ideal driving patterns with consistent speeds, moderate temperatures, and long-distance cruising. In reality, many drivers experience short trips, frequent cold starts, heavy traffic, and turbocharged engine stress. Turbochargers operate at extremely high temperatures, placing intense demands on engine oil. Over time, heat and contamination degrade oil quality, reducing lubrication effectiveness and allowing sludge formation. Independent testing has shown that shorter oil change intervals, often around 5,000 miles, can dramatically improve engine cleanliness and durability. While this approach increases routine maintenance costs slightly, it reduces long-term wear and helps preserve turbocharger health. Driving mode selections also influence transmission longevity more than most drivers realize. Comfort mode is designed to produce the smoothest possible shifting experience by allowing clutches to engage gradually. This smoothness feels refined, but generates additional heat within the transmission fluid. Excessive heat can break down fluid faster, damage internal seals, and accelerate clutch wear. Comfort mode may also lock torque converters earlier at lower RPMs, which can cause subtle vibration and internal slip. Driving primarily in normal or sport modes often results in firmer but quicker shifts that reduce clutch slippage and lower operating temperatures. Many drivers find that after a short adjustment period, the slightly more responsive shifting actually improves driving confidence while reducing mechanical strain. Electronic throttle control is another subtle feature influencing mechanical wear and driver behavior. Modern drive-by-wire throttle systems often introduce a slight delay between pedal input and engine response. This delay smooths acceleration and helps maintain fuel efficiency targets. However, drivers often subconsciously compensate by pressing the accelerator harder, leading to sudden power delivery once the throttle finally responds. These abrupt power surges can create additional strain on engine mounts, drivetrain components, and transmission systems. Selecting sport mode or customizing throttle response in vehicles that allow it can provide more immediate acceleration response, encouraging smoother pedal input and reducing sudden mechanical shock loads. Active noise cancellation is a comfort technology that many drivers never notice operating in the background. Using microphones and audio system speakers, the vehicle generates sound waves that cancel engine and road noise inside the cabin. While it creates a quieter and more luxurious driving experience, it can also mask early warning sounds that signal developing mechanical problems. Subtle knocking, bearing noise, exhaust leaks, or suspension wear often produce distinctive sounds that alert attentive drivers long before serious damage occurs. Noise cancellation may reduce the ability to detect these early warning signs. Additionally, constantly operating audio components to produce cancellation frequencies can accelerate wear on speakers and amplifiers over time. Disabling this feature allows natural vehicle sounds to be heard, helping drivers detect potential issues earlier. All of these settings highlight a balancing act between regulatory compliance, comfort, and long-term durability. Automakers design vehicles to meet emissions targets, fuel economy standards, and consumer expectations for smooth and quiet driving. These priorities sometimes require compromises that favor short-term performance metrics over extended mechanical lifespan. For owners planning to keep their Volkswagen for many years, taking control of these hidden systems can play a major role in maintaining reliability. Spending time exploring infotainment menus, driving mode options, and diagnostic settings can reveal controls that dramatically influence how the vehicle behaves under daily use. It's also important to remember that dealership software updates and service procedures can occasionally restore factory default settings. After any maintenance visit involving electronic updates or module programming, checking these settings again helps ensure preferred configurations remain active. Building a simple habit of reviewing key systems periodically can prevent unwanted changes from quietly returning. Owners who stay proactive often find their vehicles maintain smoother operation, fewer unexpected repairs, and longer component life. Volkswagen vehicles are engineered with impressive precision and performance potential. When maintained carefully and configured with longevity in mind, they are fully capable of delivering hundreds of thousands of miles of dependable service. Understanding how factory convenience and efficiency settings influence mechanical wear allows drivers to make informed decisions about how their vehicles operate. Small adjustments performed today can prevent large repair bills later, while also preserving the driving experience that makes these vehicles enjoyable in the first place. By paying attention to these hidden systems and choosing settings that favor durability, owners can transform their Volkswagen from a short-term commuter into a long-term, reliable machine built to withstand years of real-world driving.